Let's go through one more example so we get an idea of how this works. We can see from this set of ordered pairs that I definitely have a function, and because of the pattern it's taking on, I know I have a linear function. So in order to write the equation of the line that goes through this linear function, the first thing I need to do is calculate a slope. Now I can do that by counting rise over run like I did in the last example, or I can simply just pick 2 points and I can find the slope between the 2 points. Well, let's be extreme here. Let's pick this point right here, which is going to be the point -1, 7, and I'm going to pick this point down here, which is the point 2, -5. So when I calculate the slope, which is going to be the change in y, or I'm going to take y2, -5, minus 7, y1, over x2, 2 minus a -1. Well, this gives me -12 over 3, which is equal to -4. So I know the slope of the line must be -4. Now, if I were to actually draw the line that goes through these points right here, and I'm going to do my best to keep my line as straight as possible, I know that any point on this line, and I'm just going to pick a generic point. I'm going to pick this point right here. I'm going to highlight it in green. I have no idea what that point is, but I'm going to call that point xy. And I know that if I were to find the slope between this point 2, -5, and this point xy, and again, it doesn't matter which point you choose, that's the beauty of mathematics here, that I can take y minus a -5 over x minus 2, and I know that it has to have a slope of -4. And so if I do a little bit of algebra magic here, and I multiply both sides by x minus 2, then this is going to reduce out on the left, and I end up getting y plus 5 equals -4x plus 8. Notice how I distributed there. Now, I'm going to take this in a little bit different direction. I actually distributed the 4, and now I'm actually going to solve this for y. So I'm going to go ahead and subtract a 5 from both sides, and I get y equals -4x plus 3. So this would be the equation. Or I can say, if I go back to my original equation up here, it was going to be y plus 5 equals -4 times x minus 2. Both of these equations will graph the line. That's the beauty of this. And so let's just put that to the test by heading over to Desmos. All right, so here are the points we were just looking at. And let's put in our first function that we found that was similar to the last video. Y plus 5 equals -4 times x minus 2. So y plus 5 equals -4 times x plus 2. We can see that that does not go through the line. But let me go back and check my equation. Oh, it's y plus 5 equals -4 times x minus 2. So you see this feedback I got right here? I expected that line to go right through the points, but it didn't, so I must have screwed something up. So let's change that to an x minus 2, and then we can see that that line does in fact go right through the points. Now, let's put in the second equation. So I'm going to unhighlight this one. The second equation that I found was y equals -4x plus 3. It looks very different than the original equation, but it still should graph the same line. So -4x plus 3. So let's put that in. Y equals -4x plus 3. And we see that that also graphs the line that goes through the points. So I have two equations here that graph the same line going through the same points, but the equations have very different forms to them. They have a very different look, but both work. This is good news.